In every way, data centers in space, from a first principles perspective, are superior to data centers on Earth.
Let's just loft the data centers where there's infinite real estate and infinite power.
Yeah, I mean, data centers in space sounds pretty crazy. Let's look at some clips and see how this whole thing evolved. First, I want to look at a clip from around 3 weeks ago, from end of November 2025, where Elon Musk and Jensen Huang from Nvidia were talking at a panel discussion. And they were already talking about the idea that potentially you could do these data centers in space. So let's look into that.
The lowest cost way to do AI compute will be with solar-powered AI satellites.
The supercomputers we're building together, let's say each one of the racks is 2 tons, 1.95 of it is probably for cooling.
Yeah, so they were already talking about it, but at that point it was not official in any way that SpaceX would actually do that. The first official thing was this article here from Bloomberg. They said that SpaceX wants to do an IPO in 2026, raising $30 billion at an evaluation of 1.5 trillion. That was the guess back then. This was on 9th of December 2025. But this was also not really official yet because it was not confirmed by Elon Musk or by SpaceX. But then here, Eric Berger, the journalist from Ars Technica, he published an article here on X. And here Elon Musk answered, as usual, Eric is accurate. So he confirmed that it's true what he is writing in this article. And in the article itself, I mean, you can go read it for yourself, but I made a little summary here with AI. The article explains why SpaceX, after years of resisting it, is now preparing for an IPO. The focus is not traditional spaceflight, but AI infrastructure, capital scale, and Elon Musk's long-term strategy, linking AI, space, and Mars. So they want to raise more than 30 billion. The motivation is AI. And Musk believes that the race depends on building massive physical compute in space. So SpaceX already has their Starlink satellites, and they want to use that to upgrade it to be space-based data centers. So with the money they make there, they want to fulfill the Mars mission. And they say it will require trillions of dollars. And there will be a risk as well, but they are willing to take it. That's basically what Eric said in the article, and Musk confirmed it. So if we think back to the clip from Jensen Huang, I think it's impressive to think about that on Earth, 97% of the weight of these data center clusters are just for cooling. And of course, in space, it's very cold, so you won't need that. So it's much cheaper, it's much smaller, it's much more efficient. Here I also have a little clip from Ark Invest, and they're also talking about the idea.
Explain this to us, because to me it seemed like sci-fi.
Let's look into it.
On Earth, you run into scaling constraints. If you go in space, you actually can have like a lot of surface area of solar panels that are always facing the sun, and you can attach a computer to them. You don't have that big a cooling issue.
Yeah, so some really good points from Brad Winton.
Let's just loft the data centers where there's infinite real estate and infinite power.
And now finally, I also want to look at a clip from Gavin Baker.
I think the most important thing that's going to happen in the world in the next 3 to 4 years is data centers in space.
He's an investor from the US, and he's also very much into this topic of AI data clusters. So let's look what he has to say. I think he brings up some very good points also from the physical standpoint and from just efficiency and investment wise.
So in space, you can keep a satellite in the sun 24 hours a day. So you're getting a lot of solar energy. Point number two, because you're in the sun 24 hours a day, you don't need a battery. Second, for cooling. In space, cooling is free.
Yeah, I mean, it's crazy. So many aspects that could be so much more efficient in space.
Maybe each satellite is kind of a rack. How are you going to connect those racks? So if you can link these satellites using lasers, you actually have a faster and more coherent network than in a data center on Earth.
I made some notes. With the solar, you have energy 24 hours a day, so all the time, so you don't need batteries. Then also the sun is 30% more intense, which results in a 6 times higher irradiance, which is also a lot. And then there's free cooling, which on Earth would be 97% of the mass of these data center racks. But in space, it has minus 270 degrees Celsius or minus 455 degrees Fahrenheit, or 2.7 Kelvin, which is very cold, so you don't need additional cooling. And then there's also how the different data center racks are communicating, so how they're basically wired without a wire. On Earth, it's fiber optics cables, and it's a laser that goes through that cable. In space, it would just be a laser that goes through absolute vacuum, so that's even better than on Earth. It's even more efficient than through fiber optics cables. And it's also apparently more coherent. And then with the AI training data centers, you have the training and you have the inference. And on the training side, it's more important to have a lot of calculation power. And with the inference, it's more important to have a lot of speed and how you divide in which data center racks each calculation is done, so that it's the fastest way. And for speed, it would be perfect because it would be even much faster to go from Earth to the data centers in space and then back to Earth than it would be on Earth to go through all of the different stages that Gavin Baker described.
If the satellites can communicate directly with the phone, and Starlink has demonstrated direct-to-cell capability, you just go boom, boom. So in every way, data centers in space are superior to data centers on Earth.
So yeah, it's mind-blowing. Let me know what you guys think about that, and see you soon.